Nice to meet you all. My name is Yoav Degani. I'm the CEO of voicesense. voicesense is an Israeli-based company focused on speech analytics. And the topic today is behavioral predictive speech analytics. This is part of the title of this session called New AI Techniques for Call Analytics and Call Routing. That I'm the first presenter. We have other presenters as well. Last year, this topic won us an award, a Star Performer Award here at Speech Tech, and this year they asked me to elaborate and talk a little more about it. So what is behavioral predictive speech analytics? When we're talking about the main approaches to speech analysis, of course, we're talking about speech recognition, language-based, focused on the content of the conversation. And then we're talking about speech prosody, focused on the acoustics of the speech, trying to identify the sentiment and the state of mind of the speaker. But when we're considering those two main approaches, can we say that they provide personalization of the speaker that we're analyzing? Can we say that we know what is the buying style of a customer we're talking in the call center? What is the loyalty style? What are the chances that this person would churn? What are the chances that this person would buy online? Can we predict future behavior based on those main two approaches to speech analytics? The answer is probably not really. And that's interesting. These are the main approaches to speech analysis. But what we are saying is that speech analysis is missing the real personalization, the true personalization of the speaker. We can try, I don't want to waste too much time, but we can try listening to one or two examples here. No, falti. לא, זה לא דחוף עד הסוף. Never mind. We'll skip the examples, but it's not really critical. This is what I wanted to play is just a video interview of a job candidate. We get hundreds of those. You would listen to a few seconds of the call. Can you say, by analyzing the content of this call, or even the sentiment of the speaker, whether he would excel in the position that he's applying for, or if we're talking about an employee? Still not working.
No. It's coming
Never
from
mind. Leave it. Okay, this is a worker, an employee, and he's reporting at the end of the shift. They have a serious attrition problem in this organization. This is a real example from a UK, from the train system, temporary workers there. A huge amount is churning there. Can you use content, speech recognition, or sentiment and predict whether this person would churn or not? Does he tend to be stable at his job and so on? The answer, and there are many different examples. Here I have an example in German, a depressed patient. Again, can you say, just by analyzing the voice, whether the content or the sentiment, whether this person is depressed? The answer is no. And this is the idea of behavioral speech analysis. It is to find answers to those questions, to be able to provide true personalization, reflecting the speech patterns and the behavioral patterns of the individual. We have two focuses when we're talking about behavioral speech analysis. First is classifying people into general behavioral tendencies groups. For example, personality is the classic one, but does someone tend to buy online or not? What we're trying to do here, we know that this is a personality issue. Some people tend to buy online, others don't. They're reluctant to give their credit card details or whatever. So if we take all the people that tend to buy online and we analyze their speech patterns, can we find the common features that separate those people from people who tend not to buy online? This is exactly what we're trying to do when we're talking about behavioral speech analysis. This is one aspect. And here we're not looking for the specific speech patterns of the specific individual. We're looking for the speech patterns of the entire group. But the other focus is the individual one. Think of a depressed patient. We want to learn, to study his specific speech patterns, and we want his baseline. How does he sound when he's not depressed? Then we want to track him on a daily, weekly basis and see changes in the speech patterns that indicate, assuming indeed the speech patterns reflect his inner state, then we can track changes in his speech patterns that indicate of changes in his mental health state. This is a real personalization. And the main value of those two focuses is that it provides prediction. Because if we know that someone tends to buy online, we can predict that he would buy online. Of course, this is AI. We're talking about statistics. We are not correct all the time. But that's the idea. How do we do that? We link, we learn what are the typical speech patterns that are associated with different behavioral patterns. And we measure over 200 different speech patterns, prosodic speech patterns, every second when we analyze speech. So with one sentence of 10 seconds, we already have thousands of measurements. Put into the AI, the machine learning processes, we come up with those associations between the speech patterns and the behavioral patterns. Overall, when we're talking about behavioral speech analysis, it's a big promise. The main promise is that it is indeed a true personalization. We can provide a complete personality profile or behavioral profile of a person. Coupled with that is the predictive power. Once you know the behavioral tendencies, you can anticipate customer behavior. But we're talking about behavioral patterns, personality. It is so wide, it's relevant to a very wide range of uses, not only for the call center or the enterprise, because our behavioral tendencies affect any decision we make, whether we're talking about consuming, whether we're talking about entertainment, health, work, and so on. So it's really a wide promise. And it's language independent. We're using the prosodic features that are generated by the speech production mechanism. So it's common to all humans. And so language independent. Objective. One of the problems with emotion analysis is that emotions are subjective. You have to ask the person what he feels, or you have to put several raters to see whether you're correct or not, and nobody knows whether it's true. But here, once we provide a prediction, it can be easily validated. We predict that the person would purchase. Just go and see how correct were we with those predictions. So we're talking about an objective analysis as well, and it's lasting. One of the problems with speech analysis is that it focuses, with the traditional approaches, that they're focused on the current moment, what was said right now, what was the sentiment right now. It's not relevant for the next call, but if we find typical speech behavioral patterns of a customer and it's put into the CRM, then when the customer calls a year later about a different issue, we can use the same analysis to predict what would be the behavior. That's the concept. Let's see a little more how it is done. So I mentioned already analyzing prosodic analysis, language independent, measuring over 200 different parameters every second. We use that to determine the typical speech patterns that are characteristics of the individual. And then we associate them with typical behavioral patterns. This is, of course, done offline, machine learning. This is the main achievement. Once we have those behavioral patterns, we generate the predictions relevant to the specific use case at hand, but we don't care. Now, it's relevant to a wide range of markets and use cases. Of course, the enterprise predictive analytics, we actually, this is an important thing, we do not perceive ourselves as a speech analytics solution. We perceive ourselves as a predictive analytics, as part of the big data, and we're bringing the unique behavioral aspect instead of the typical demographics and customer history and so on. So it's one general speech platform that supports many different use cases, whether it's predicting sales, retention, risk behavior, customer experience at call centers, agent performance, personal assistance, whether it's mobile, whether it's smart speakers, video interviews, healthcare, as I mentioned, fintech, loans, collections, and many more. Game-changing differentiators. I mentioned the big data approach, language independent. In the healthcare, we're talking about a physiological biomarker for mental health illnesses. There aren't biomarkers for that yet. It's fully subjective. The psychiatrist has to decide manually about the current diagnosis. So this is a breakthrough medically, not only part of the big trend of mobile health and digital health. I mentioned objective and, of course, remote and automatic. Let's see a few examples just that you see what we're talking about. This is an example, a case study from one of the banks that we're working with. Here we had 770 people who took loans. We classified them based on the speech patterns to 3 risk groups, low, medium, and high, regarding whether they would default on their loan or not. And as you can see, those that we predicted are at high risk default. 27% of them defaulted, as compared to only 6% at the low risk group. Of course, this is highly valuable. Of course, we're not waiting years to see whether they defaulted. We're just taking historical calls where the bank already knows who defaulted and who not. And of course, this is highly valuable for the banker for the decision whether to approve the loan, at what premium interest, and so on. Another example, collections. In this case, we had 4,000 debtors. We divided them into 5 risk groups, whether they would repay their debt or not. Those that we marked as high risk, 50% was the average failure in the sample. Those that we marked as high risk, 83% didn't pay. Those that we marked as low risk, only 25% didn't pay. This prediction is working. Let's see another example. Attrition, employees. Again, 4 times. Those that we predicted as high risk, 22% churn in the coming months. After we analyzed only 1 call. Those that we said low risk, only 5% churn. Hiring. We analyzed 11,000 video interviews for these specific customers. Everyone went through the regular hiring processes. So we know that 15% were hired overall. We were able to filter, to screen out 70% of the candidates, their average hiring rate was lower than the average in the sample, while the 30% that we marked as matching had 2 times and 3 times higher hiring rate than those that we marked as low. And finally, healthcare. This is from a clinical trial in Hamburg, Germany, running these days. Here we demonstrated the correlation between our assessment of depression and a full, complete psychiatric evaluation taken by the psychiatrist in Hamburg. And you can see that we have excellent correlation, not written here, but overall, we had 143 patients here. You can see that overall we had a 70% agreement between our assessment of the depression and the psychiatrist. 38% we marked as low risk, they were mild. 31% we marked as high risk, they were moderate severe. And this is based on analysis of one call. With depression, we're analyzing many calls on a daily and weekly basis. Okay, so these are some examples of what we're doing. Best practices, machine learning, you're all familiar with, always a training and a test sample. Analyzing those 200 parameters that I mentioned, tagging them, doing all the statistical correlation, building the model, cross-validating, and then testing it on a different, separate test sample. And the results are all based on the test sample. One word about the architecture. So, as I said, one complete speech platform. One part deals with fetching the audio. We don't care whether it's a call center. We integrate directly with the PBX to get streaming audio into our server. But it can be recorded files uploaded to our servers. It can be mobile. We have a mobile application that sends the audio directly to our cloud servers. The second server does all the signal processing. We can analyze hundreds of calls simultaneously. We're running 2,000 times faster than real time. And then the third server is calculating the high-level predictions and integrating with the organization databases, whether the CRM, whether the underwriting system, and so on through APIs. So one speech analysis platform supporting all the different use cases that I mentioned. Then we provide real-time indications. We need about a minute into the call. Let's say a banker is talking with someone who requests a loan. About 1 minute into the call, we will present this real-time indication with the risk score that we associate with this person. In this case, it's a sales guidance, but it can be fintech guidance, offline reports. This is our mobile application that collects the audio and can send back the analysis results as well. And this is the overall outcome. This is what we do. Thank you very much.